When counting events and the way they can happen, I can use three ideas. One is the tree diagram. Well, here you can see why that is called a tree diagram, because it looks like the branches of a tree. A table in which I can, name all the possible combinations of resulting menus in this case, outfits in this case. And one that requires definitely the counting principle, because to organize a table or a tree diagram is not very practical, and it would require a lot of material. To start with the menu, you go to a restaurant, and here I'm including only a few items to consider. The entry, right? So for entries, I'm considering empanadas and French fries. For main dish, I'm including chicken, beef, and fish. And for dessert, I'm including only 2 items, apple pie and cheesecake. So you can organize the results, count the possible results, the possible outcomes of combinations in a table like this one. So if I use the multiplication principle, here for entries I have 2 possibilities, times 3 for main dishes, 6 times 2 for dessert, 12 possible combinations, so 12 possible menus. Here I can see the possible combinations, so here this one corresponds to empanadas, chicken, apple pie, empanadas, chicken, cheesecake, etc. And if you count them, you have the 12 possibilities. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice that the table is organized in such a way that comes from a tree diagram, for example. And I know there are 12 possibilities because, as I said before, I used the multiplication principle for counting. So if entry happens in 2 different ways, main happens in 3 different ways, and dessert happens in 2 ways, basically to get the possible outcomes or combinations, I multiply 2 times 3 times 2, which is 12, as you can see here. Now for the outfits, I have here 2 different color caps, so red and green, 2 different color t-shirts, green and yellow, and 3 different color shorts. So here you can see red, yellow, and green. The question here is, how many outfits can I organize? Again, if I use the multiplication principle for counting, I see that 2 times 2, 4 times 3, 12. And here, in this case, I'm going to organize this in a tree diagram. Of course, I can also organize this tree diagram in a table, or this table in a tree diagram. So for the cap, I have 2 possibilities, red and green. If I select red, I have 2 possibilities for t-shirts. Those are green and yellow. Something similar happens if I select green cap. I have 2 possibilities for the t-shirts, so green and yellow. And suppose I select red cap, green t-shirt, I have 3 possibilities or 3 possible combinations for shorts. Red, yellow, and green. So here I'm organizing the 2 possibilities for cap. Every time I select a cap, I have 2 possibilities for t-shirt. So here, and in this case 2. And every time I select a cap and a t-shirt, I have 3 possibilities for shorts. So as you can see here, red, green. So here we have 12 combinations. 2 times 2, 4 times 3, 12. So here would be the 12. Red, green, red, that stands for cap, t-shirt and shorts, etc. If I combine those, red, green, yellow, red, green, green, red, yellow, red, red, yellow, yellow, red, yellow, green, and the same combination here with green cap. So green, green, red, green, green, yellow, green, 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 yellow, red, green, yellow, yellow, green, yellow, green. This example actually requires the counting principle, because to organize a tree diagram or a list would take a lot of time, and the exercise won't be very practical. Why? The license plates here in Colombia, for example, I'm taking one example of Bogota, but these ones go from AAA000 until ZZZ999. So how many possible license plates can be made applying these conditions? What are the conditions? 3 letters and 3 digits. I just drew this line here so you don't confuse this with 000. These are 000. And remember how many digits are there? 10, because I'm counting the 0, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. For the first letter, I have 26 possible outcomes. For the second, I have 26 as well. You know, if you count the letters on in the alphabet, not considering the double consonants or the ñ in Spanish, right? Those are not including license plates. So for the first letter, I have 26 possibilities times, using the counting principle, 26 for the second letter times 26 for the third letter times 10 for the first digit, times 10 for the second digit, and times 10 for the third digit. So if you perform this operation of multiplication, you will find that by using the counting principle or multiplication principle, you will get that following these conditions. So here's one more example. This is any other license plate. This is E851, so it's part of this huge list that I won't be able to complete using a table or a tree diagram. So I know that for sure I will get 17,576,000 license plates with this combination. And, well, maybe as an exercise, as an additional exercise, you can try to find the combination of license plates like this one, in which these were used actually in Colombia a few years ago, you know. So they had only 2 letters and 4 digits. How many possible license plates can be done with this? Maybe that's a good exercise. And these ones are actually used nowadays for motorcycles. As you can see, some of them are using 3 letters, 2 digits, and some others are using 1, 2, 3, and 4 letters and 2 digits. How many possible license plates can you make in this case or in this case? That would be a good exercise, right? But remember, for these ones, the best idea is to use the counting principle, the multiplication principle.